Dear students, so from last classes, before this unit test, we were doing chapter Metallurgy, and in that where we were last time is regarding extraction of aluminium. We did what is step number 2? Step number 1 is crossing and grinding. That we did crossing and grinding. Then step number 2 is concentration of ore. So up to concentration of ore we did the last class. Okay. So what is the main ore or chief ore of aluminium? It's bauxite. And what is the molecular formula for bauxite? It is Al2O3.2S2O. Is the molecular formula for bauxite. And first of all, bauxite is grinded, and then this grinded bauxite is how can we do concentration of bauxite ore? There are 4 processes, and we'll be doing chemical method for this. That means solvent extraction. So we'll be taking a solvent, and what is the solvent for concentration of bauxite ore? That is sodium hydroxide solution, that is caustic soda. So whenever we add caustic soda and this powdered bauxite, then we'll get sodium metaaluminate. Sodium metaaluminate in solution as a filtrate, and then in the residue we'll be getting iron oxide and then this tin oxide. Okay, so this can be separated in the form of residue, and the residue is called red mud. Red mud. Then this sodium metaaluminate is further hydrolyzed, and on hydrolysis of sodium metaaluminate we will be getting aluminium hydroxide as insoluble substance and sodium hydroxide. And further drying this precipitate aluminium hydroxide, drying, then again igniting it, will be getting alumina. Will be getting alumina. So what is the molecular formula for alumina? It is Al2O3, aluminium oxide. So alumina is also called aluminium oxide, other name. So aluminium oxide now. This aluminium oxide is already in the form of oxide. So for extraction of aluminium, step number 3, that is roasting and calcination, is not done. Because roasting and calcination is the process of converting ore to oxide. Ore to oxide. So whenever you are asked a question, which process of oxidation will follow for extraction of aluminium, it is roasting or calcination, then you will be saying no of them. Because we will be getting aluminium oxide directly from step number 2, that is concentration of ore using chemical method. So for extraction of aluminium, no need of roasting and calcination. So we'll be going directly to reduction. Reduction of oxide to metal. Reduction of oxide to metal. And in this again, we cannot reduce aluminium oxide to aluminium by very common reducing agents like carbon monoxide and hydrogen, because aluminium oxide is a very stable compound. The attraction, the affinity of aluminium towards oxygen is very high. It cannot be reduced very easily by these reducing agents. So in metal reactivity series, from potassium to aluminium, zinc, iron, zinc, this potassium to aluminium cannot be reduced by simple reducing agents. So for this kind of oxides, we'll be using electrolytic reduction. And in this again, for separating this aluminium from aluminium oxide, we have to remove oxygen, right? So for that we need to heat aluminium oxide, and melting point of aluminium oxide is 2000 degrees Celsius. So if we melt this aluminium oxide up to this temperature, then again all of the metal will get melted. So this electrolytic reduction, the use of this electrolytic reduction is also not very simple, not very easy for aluminium oxide. That's why Hall, the scientist Hall, he found the process, he found the solution for this problem. So when cryolite is added to alumina, this cryolite can reduce the melting point, the fusion temperature of alumina from 2050 degrees Celsius to 950 degrees Celsius. Only then it can be treated as electrolyte. So today we will be doing this process called Hall-Herold's process. That is extraction, reduction of aluminium oxide to aluminium. Reduction of aluminium oxide to aluminium can be done by the process called Hall-Herold's process. So today we will be doing Hall-Herold's process. So electrolytic reduction of alumina to aluminium metal. So what is Hall-Herold's process? It is the electrolytic reduction of alumina, Al2O3, to aluminium metal. So how do we do? Let's see. For this, we have to follow the process called electrolysis. That means decomposition of a compound. Decomposition, it is electrolysis is a decomposition reaction. So how is this decomposition reaction carried? If this decomposition reaction is done by passing electricity. By passing electricity. Okay? So for electrolysis we need electrolytic tank. We need electrolytic tank, electrolytic vessel or electrolytic tank. So what is electrolytic vessel or electrolytic tank? It is iron tank lined with heat resistant material like carbon with a sloping floor for removal of molten aluminium. So electrolytic vessel will be seen in the figure. The figure will be coming up. So electrolytic vessel is a container in which is made up of iron. Electrolytic vessel is a container, is a tank made up of iron, and inside this iron it is lined with carbon, because carbon does not allow heat to go out. It does not allow heat to go out with heat resistant material like carbon. That means carbon can absorb heat. Carbon can absorb heat. So it is heat resistant material. And this vessel, this electrolytic vessel is made a sloping floor. So why it is made slopy? So that molten aluminium can flow very easily. So why electrolytic vessel, like especially for extraction of aluminium, is slopy? For the removal of molten aluminium, it is slopy. This is one of the requirements for reduction of alumina is electrolytic vessel. Then another requirement is electrolyte. Electrolyte. So what is electrolyte? It is the solution that conducts electricity. It is the solution that conducts electricity. Because solid, okay, metals only can conduct electricity when they are solid. But ionic solids, okay, ionic solids, they can conduct electricity when they are fused, when they are melted, when they are converted into solution. Because here in ionic solids, what carries charge? Ions carry charge. And how they can be converted into ions? By breaking them. By breaking them. Okay, by melting them, they can be converted into ions and they conduct electricity. But for metals, they can conduct electricity when they are in solid form itself, because their charge carrier is electron. But in ionic solid, charge carrier is ion, hence they need to be melted or fused. So for conducting electricity, this alumina need to be fused. Alumina need to be fused. Okay, and fusion temperature of alumina is 2050 degrees Celsius, which is very high, which cannot be given. So we need to reduce this fusion temperature. So how can this fusion temperature be reduced? By adding cryolite. So that means electrolyte for reduction of aluminium oxide contains three components. Three components are there. One is alumina, that is required. Okay, that is the basic thing from which we are going to extract aluminium. Number 2, cryolite, and number 3, fluorspar. So why is cryolite added? So that it can reduce fusion temperature of alumina from 50 degrees Celsius to 950 degrees Celsius. It enhances conductivity. And fluorspar is added. It also enhances conductivity of alumina. So electrolyte used for extraction of aluminium contains three components, that is cryolite, alumina and fluorspar. And what is the ratio? Alumina 1, cryolite then 2, and fluorspar 1. So 20%, 60, 1:3:1. 1:3:1. 1 part of alumina, then 3 part of cryolite, then 1 part of fluorspar we have to add. So it is the main compound yielding aluminium. So out of these three components, from which we are going to get aluminium? From alumina. And why we are adding cryolite then? In order to reduce fusion temperature of alumina. And why we are adding fluorspar? Because it increases conductivity. So cryolite is, what is the molecular formula of cryolite? Na3Al(F6). It acts as a solvent and lower the fusion temperature from 2050 degrees Celsius to 950 degrees Celsius. And fluorspar is CaF2. Molecular formula of fluorspar is CaF2. It also acts as a solvent and increases the conductivity of electrolytic mixture. So it reduces the fusion temperature of alumina. It increases the conductivity. And all of these acts as the solvent, acts as the electrolyte. What is electrolyte? It is the solvent or the solution that conducts electricity. So what are the electrolytes? What are the components present in the electrolyte for reducing alumina, cryolite, fluorspar and alumina? So what is the function of cryolite? It acts as a solvent and reduces fusion temperature from 2050 degrees Celsius to 950 degrees Celsius. What is the function of fluorspar? It acts as a solvent and enhances conductivity of the mixture. Okay. Then electrodes. So for electrolysis, one thing we need is vessel, that is electrolytic vessel. Another we need is electrolyte, and here the electrolytes are alumina, cryolite and fluorspar. And another thing we need is electrodes, rod. Electrodes are the metal plates through which electricity gets into the electrolyte and leaves the electrolyte. So that is electrode. There are two electrodes. One is anode. Anode is positively charged electrode. And one is cathode, which is negatively charged electrode. Anode is positively charged electrode. Cathode is negatively charged electrode. So here, what is the anode? Anode uses the carbon rods. Anode used in this process, in this electrolytic reduction, is thick carbon rods, and cathode is inner carbon lining of electrolytic cell. So in electrolytic vessel, I was saying you there is inner lining. Okay, inside this iron tank there is inner lining of carbon that acts as anode. That acts as cathode. And what is the temperature maintained? Temperature maintained is 950 degrees Celsius. Then what is the voltage used? Voltage used is 5 to 6 volts. Why is low voltage used? Low voltage is used to avoid decomposition of the molten cryolite. So our intention is not to melt, not to reduce cryolite. Our intention is to melt alumina. Our intention is to melt alumina, not to melt cryolite. Otherwise, we will not be getting pure aluminium. So, in order to get pure aluminium, only alumina is to be melted, not cryolite. So, if we use more than this voltage, then cryolite will start melting and will not get pure aluminium. Okay, so voltage is maintained very low, that is 5 to 6 volts, and powder coke is used. Powder coke is sprinkled over the surface of the electrolytic mixture. It reduces heat loss by radiation. So, what is the function of this powder coke, which is sprinkled over the surface of the electrolytic mixture? It reduces heat loss by radiation, number one. Number two, it prevents the burning of anode. It does not allow anode to burn. It does not allow anode to burn. Now this is the picture. This is the picture. Now so you can see here. Now I can show you the things out here. This container, this vessel, is called electrolytic vessel. This complete vessel is called electrolytic vessel. And you can see here this lining, this inner lining, okay? This inner lining, you can see a complete inner lining. Yes? This inner lining is carbon lining. This is gas carbon lining. This carbon is in the form of gas carbon lining. This is gas carbon lining which acts as negatively charged cathode. To this lining, negative terminal of the battery is linked. So this becomes cathode, this lining. And this lining is made up of gas carbon. So what is the cathode used for the electrolytic reduction of alumina? Gas carbon. This gas carbon acts as cathode, acts as negatively charged terminal. Then this is positively charged. So this positively charged terminal is linked to this plates. So you can see here three plates are used here. These are called electrodes. What are these? Electrodes. And electrodes used in this particular reduction is carbon rods. So thick carbon rods acts as anode, positively charged anode. Okay? And here you can see this. You can see here. These are powdered coke. Okay, they are sprinkled over these anodes. So why they are sprinkled over anode? So that it can reduce heat loss, because these are carbon rod which absorbs heat. That means they get heated and they may lose heat. But this powder coke does not allow loss of heat. Whenever there is loss of heat, again 950 degrees Celsius temperature is not maintained. It should not be less than 950. Otherwise, alumina will not melt. Alumina will melt in presence of cryolite at 950 degrees Celsius. So, this powder coke is sprinkled in order to reduce heat loss through radiation, and in order to prevent this anode to get oxidized, because oxygen generally comes in contact with this and it may burn. Okay, so it reduces the speed at which this rods converts to carbon dioxide. Now, this is carbon rod, this is iron tank, this is fused cryolite, alumina and fluorspar. This solution, there is a solution, okay, this solution, electrolyte. This solution, up to this is the solution which conducts electricity. This electrolyte contains cryolite, alumina, and then fluorspar. And whenever this process goes on, then alumina starts melting. Then fused aluminium can be collected through this tap. So this is tapping hole. So this is tapping hole through which molten alumina can be collected. Now let's see what happens during this. So electrolytic reactions from alumina. Whenever alumina decomposes, I said electrolysis is a decomposition reaction. So whenever aluminium decomposes, it decomposes to give aluminium ion and oxygen ion, oxide ion. Aluminium ion, oxide ion. And whenever this cryolite decomposes, this gives sodium ion, aluminium ion, and chloride ion. And when this fluorspar decomposes, it gives calcium ion and chloride ion. Okay? So these are the components, these are the chemical substances present in that electrolyte. So alumina decomposes in aluminium and oxide ion. Cryolite decomposes into sodium ion, aluminium ion, and chloride ion. Fluorspar decomposes into calcium ion and chloride ion. Now there are how many positively charged ions? 1, 2, 3, 4. That means these are same. So there are 3 cations. How many cations? How many types of cations are there? 3 types of cations: aluminium, sodium, and calcium. Now you just think chemical reactivity series. In chemical reactivity series, aluminium lies below sodium and calcium. Aluminium lies below sodium and calcium. That means whichever metal lies below in the metal reactivity series, they will get higher preference for the discharge. They will get higher preference for the discharge. That means out of these 3 cations, aluminium is discharged. Aluminium is discharged. Rest of the things will be there in the solution only. But aluminium will be discharged. Okay? Aluminium, and what is the charge of aluminium? Positive. So positively charged ions moves towards negatively charged electrode. It moves towards negatively charged electrodes. That means here this aluminium moves towards, aluminium is also there, then sodium is there, then calcium is there. Out of these three, this is lying low in the electrochemical series, then sodium and calcium, hence these can move towards cathode. Positively charged moves towards negative, so aluminium comes towards this side. And this will be there in the solution only. Okay. Then out of negatively charged ions, there are 2 types, oxide and fluoride. Here also fluoride, and here is oxide. So out of this oxide and fluoride, here also less reactive will get more preference for the discharge. That means fluorine will be there, fluoride ion will be there in the solution only. So fluoride, whenever this all decomposes, then cations will be getting these three types of cations, and aluminium moves towards cathode because it lies lower in the electrochemical series, hence it gives high preference for the discharge. And out of oxide ion and fluoride ion, oxide ion gets higher preference for the discharge, and it moves towards anode. And anode is positively charged. So Aluminium moves towards cathode and oxide ion moves towards anode. Aluminium moves towards cathode and cathode are electron rich. So aluminium on moving towards cathode, at cathode. What happens at cathode? Aluminium gains 3 electrons from cathode because cathodes are electron rich. So it becomes aluminium. And at anode, what happens? At anode, oxide moves and gives 2 electrons. It releases 2 electrons here. And it becomes O, oxygen. And this oxygen plus oxygen makes O2. That means aluminium is deposited at carbon lining. Okay, and this fused aluminium, molten aluminium, because iron is very hot. So this aluminium, whatever is deposited, will get heated and molten aluminium is collected. Molten aluminium is collected through this tap. So this is depositing in this line. And since this iron is very hot, so this will be melted and this molten aluminium is collected here. It is condensed and they will get pure aluminium. And negative ion, that is oxide ion, moves towards these plates. And gives electrons here because this is electron deficient. So it gives electrons here and becomes oxygen gas. And this oxygen gas, when comes in contact with these are made up of carbon only. So when this oxygen gas comes in contact with this carbon, then it forms carbon dioxide. That means these plates will decay, will destroy, forming carbon dioxide. Hence, these anodes need to be replaced time to time. So this is the electrolytic reaction. Now at cathode, what happened? I said cathode, negative terminal, inner lining of tank. That means inner lining of that carbon acts as cathode. They are negative terminal and rich in electron. So sodium, aluminium and calcium ions migrate, but aluminium ions are charged on account of their lower position in the electrochemical series. Okay, so aluminium ion on reaching cathode, not in the solution, on reaching cathode gains 3 electrons and becomes aluminium. And aluminium formed sinks to the bottom of the tank and is periodically tapped off. So this aluminium, whatever is formed, will sinks to the bottom of the tank. Okay, because iron vessel is very hot. So aluminium, whatever is depositing, will be melting because gas carbon is used there. So it cannot trap it. So this aluminium comes towards the bottom and is collected periodically, opening the tap. Again closing, again opening that periodically tap off. Okay, so this way aluminium is collected. Now at anode, what will happen? Positive terminal, anode is a positive terminal, and carbon rods deficient in electron. Oxide and fluoride ion migrates towards anode. However, only oxide ions are discharged on account of their lower position in the electrochemical series. So O2 minus gives 2 electrons and becomes oxygen atom. This oxygen atom does not exist independently in nature, hence it combines with another oxygen atom to form oxygen molecule. So this oxygen molecule comes in contact with the carbon in the carbon. At anode, that is positive terminal, which is made of carbon rods, which is deficient in electron, oxide ions and fluoride ions migrate towards anode, which is positively charged. So mind you one thing, in electrolysis, positive moves towards negative rod and negative charge, negative ion moves towards positive rod, positive ions, cations moves towards cathode, anion moves towards anode. Okay, so these are anions, they move towards anode. But which will get more preference? Oxide ion. Why? Because among oxygen and chlorine, oxygen lies lower in the electrochemical series. Hence, oxygen will get more preference. So, discharge on account of their lower position in the electrochemical series. Hence, oxide ion reaching this anode, which is deficient in electron, loses electron. 2 electrons it loses and becomes oxygen atom. Oxygen atom cannot exist independently. Hence, it combines with another oxygen atom and becomes oxygen gas. This oxygen gas combines with this carbon rod and forms carbon dioxide gas. That means gas can come out, can release it. This gas can be evolved. So carbon rod will be decaying, will be decomposing, and finally it will totally vanish. That's why before it vanishes, this anode has to be replaced. This anode has to be replaced. So, because of this only, the anodes get worn out and have to be replaced from time to time. An indicator lamp, so just in this figure, we could see here, this lamp is here. Why this lamp is here? This is control lamp. This is control lamp. So this lamp is connected here. So what is the function of using control lamp here is that here in this electrolyte there are alumina, then cryolite, then fluorspar. Okay. So what happens is whenever alumina is reducing, because from alumina, aluminium is deposited, pure aluminium is deposited. So composition, the content of alumina, whenever it falls in the solution, then voltage increases. Automatically voltage increases. Okay, automatically voltage increases whenever alumina is reduced in the solution. So voltage increases, and when this voltage increases, then this bulb glows. So whenever this bulb glows, what we need to understand is whenever this bulb glows, that means we have to add alumina here in the electrolyte again. We have to add more alumina time to time. Time to time we have to add alumina, because this alumina is melting and then we are getting molten aluminium. So alumina, whenever this bulb glows, what we need to understand means alumina is about to finish in electrolyte. So we need to put again alumina in order to get pure aluminium. So the work of this control lamp is to indicate that you are supposed to add more of alumina. You are supposed to add more of alumina because the voltage is increasing, which means it needs more of alumina. Okay. So alumina, soon as the concentration of the alumina in the electrolyte glows, as soon as the concentration of the alumina in the electrolyte bath falls below the minimum required level. So whenever alumina, concentration of alumina in the electrolytic bath reduces, minimum required level goes down, the minimum required level, below the minimum required level, then the bulb glows. More alumina is added to compensate the loss and to keep the process working. So if you will stop putting alumina, then the process will stop. So in order to continue the process, in order to continue getting aluminium, pure aluminium, you need to go on adding alumina whenever the bulb glows. Whenever the bulb glows. So when the bulb glows, when voltage jumps. Actually, what is the voltage maintained? It is 5 to 6 volt. But whenever the bulb glows, by the time the voltage of the will be around 40 to 50 degree or 40 to 50 volt. So voltage will be 40 to 50 volt. So this, how do indicator lamp glow? How do indicator lamp glow? So I said the voltage jumps from 40 to 50 degree. Voltage jumps from 40 to 50 volts. This indicator lamp is placed in parallel with the cell. When the most of the alumina is used up, the resistance of cell increase. The resistance of the electrolytic cell increase. Hence, the current means resistance increase means voltage also increases. Ohm's law. So